Really, just have a couple of slides here to wrap up with, but I just wanted to look at, what does a typical support case or a typical user resin might look like. And, we get users with all experience levels. So, sometimes we're getting people with very minimal software programming background, so maybe they really are just at the IT level. But they're tasked with maintaining the stack still, and that's where they are glad that they have the Resin Help monitoring. So the names have been changed here, and we'll just take a look at a case. So typical case might come in and says, hi support, we had a customer get an out of memory error on Monday. Unfortunately, they restarted Resin and didn't get us a PDF summary. My question to Caucho is, could a lot of block threads cause an out of memory error? Okay, and that just is one of the typical. We don't really have a lot of information to give to you, but can you tell us why our application restarted? And support at the time said, from my experience, it's the other way around because of the garbage collection thrashing. Low memory would usually trigger a bunch of block threads. Okay, and so the next occurrence of dialogue came like this: hi support. This same customer had to restart their app server on this date, as well with an out of memory error. JVM log. It was at this time, and that time a report was generated. And they said, it looks like the CPU shot up to 100%, but I can't tell from the report why. Do you see anything I'm missing? And they attached the log file. So let's just briefly look at the actual log file that they sent over to us. Okay. So okay, so this is what a typical PDF report will look like. Gives you the time that the information was generated. It'll go ahead and give you your environment information here. Some top level resources, your swap space file descriptors being used, as well as your configuration. So, considering how many virtual deployments are out there and how many people are deploying in, Amazon EC2 instances or a hybrid cloud, they sometimes have their configuration running and they get the PDF report and they say, oh, that's not the right configuration running, no wonder. So sometimes it's as simple as looking at something like this level of the PDF report, and that answers all the information we need. But usually we scroll down a little bit further here. So in their PDF report, what we see here is first the port threads. So they had about 1,500 active on 8080, and for the scoreboard. So here is the printout of their threads on 8080, and pretty much all of them were blocked. We have a couple running here, but the B's that are being printed out is a block thread. So, right when they get to this area, we can see that, clearly there's something wrong with the application. You shouldn't have this many block threads going on. So the health at the time was fatal, so you get this nice little fatal graph, some health check statuses. So whenever the health checks ran, you're going to see the information that was printed out here coming to the side. So 81% free, and then 89% free, and then or 81% they had memory permanent gen free. Here. So the downtime that they suffered was actually 8 minutes, so almost 9 minutes there. And so then we could look at some of the health events that were triggered. So some of these are custom health checks that they might have, but a lot of them are the default health checks that Resin will do itself. So it looks like their license was expired for quite some time. But of course they said, oh, our license is expired, but we're going to handle that. But can you help us right now with our downtime? So looking at the cluster status, really they just had it deployed to one server, I believe here. So no dynamic servers were in use here. We can see that their request active kind of tails off there. Their CPU, so usually they're around here. And again, the anomaly detector, if ever gets up to, you can set it to 10%, 20%. And so if you would have had a spike happen here, it would have generated the PDF report during that time for you. Their CPU hit 100%. context switching and load averaging. And here's JVM memory, physical memory, charts that we provide as well as some of the log warnings. So as we can see, it's got pretty severe. That's when the restart happened. Now they're looking to know why it restarted. They're not looking to know, or to help them get up and running. The good news is that the Resin server did restart. Once it restarted, cleared everything, and the application was back up and running. But again, that kind of leaves them out in the dark in terms of why did it restart. Well, if we examine a bit more the JVM threads, we can see that, just another representation that we saw earlier, that their thread count was almost completely full of blocked threads. And so, database, they also had this particular case that turned out to be a database issue as well within their app server code that was going on. So when we look at, here we go, the heap dump. It wasn't too useful for us here, but again, it just gives you a snapshot of what your system looked like. So it is useful for people who are doing fine tuning and things of that nature. They do, anomaly detection does allow you to take a look at some of the statistics here, so we can see what's going on there. Primitive memory usage, and the real problem is going to start. So right here. So the thread dumps are usually the best indicators of what was going on. And we see that they had one thread running for 8080. Looks like it was doing, JDBC driver, trying to actually do a set for their, do an update into their database. They had this thread here blocked, and then they had this thread here, 149.644.85. And this is the last thread. It's runnable. Everything else is pretty much blocked, waiting on it. So all the other threads are blocked, and they're all waiting on that thread stack trace. Well, the one currently right after it, we can see that we have this unbounded local cache store.get running. Sorry, it's blocked, but it was waiting on the process owned by this this thread running here. And it was a little bit odd that you would have some sort of cache git that's responsible for blocking your threads. So what did support say back from here? Well, so let's see. That was just one of the likely culprit. So what support handled back was, well, the likely culprit is that COM, Natopia, MBBS's cache, unbounded local cache store. So they were running out of JVM memory, and when you see there it says the following stack trace looks highly suspicious. That was the previous stack trace we were talking about. So one of the value was not found in the cache, or loaded from the database, but two, the other threads trying to get a value from the cache cannot proceed because it hasn't been blocked by number one. So in summary, it was that the primary issue was that the unbounded local cache store may be storing too much in memory. We weren't exactly sure without looking at some of the lines of code within their application, how they were using it. But the secondary issue is that the unbounded local cache store is blocking other threads if the database or the JVM is slow for any reason. So given these two items that we really just pulled from their PDF report, they made some small changes in their code, and they were back to getting 100% uptime, or 99.99. No more JVM error messages, and that log file was very helpful for them to sort of trace that down. That PDF report. So that's really some of the back and forth that happens. Getting the right PDF report is sometimes an issue. But just because we give these things out as a default setup, and people are kind of unaware that Resin is doing all this stuff for them in the background, keeping track of their system. So just one other small look at another portion that was pulled before. We had what we were dealing with was session corruption. I'm sorry, their servers were crashing, and they had huge clustered persistent sessions. And we had asked them, what's the size of their sessions, and they had said, we're not really storing too much. We're not really storing. They don't believe they're storing too much. The Resin sessions, the way they work is the first 3 letters really determine which server it goes to. So AAA, BBB, CCC is how we give the session cookie. And the last save length is something that's available to be looked at through the Resin admin or the CLI. Most of them were small. We had one of them here, and I believe I cut off another one that you start to get almost to, well, that one there was 0.13 megs, but what they ended up having were huge sessions that they were really just at every end of every request storing everything in their session. And when Resin is shifting all that data around in the cluster, going to run into some memory issues. So this printout page here was all that they needed to look at. And once we contacted them, they went back and looked at what they were storing in their sessions, why they were using so much session storage to begin with, and then from here they made some changes, and they're again running 99.99% uptime, no reported issues, and they have great insight and know where to find the files at now. So usually the first request is, can you send us the PDF reports? And the email comes back and says, well, where are the PDF reports? And we say, well, here they should be here depending on your installation. But once we get their PDF report, again, not a replacement for Nagios, but really gives us what we feel like is the pertinent information for solving issues. We handle all of our support over through email. So we have done a couple on-site interventions for people local that are around here. Actually, we're just up the road in Carmel Valley. But our PDF report gives us the same insight that we're going to really be able to get from being on site there. And in fact, sometimes it gives us it faster because we're more familiar with looking at it. So, but the company had the money to pay for on-site time, so we were on site. But that really concludes, high availability within the Resin Application Server. So, thank you guys for coming out, and of course, I'll take any questions.
Could you go over a little bit the monitoring of this? I mean, I know you talked about having some monitoring of each individual application server and JVM, but how is it actually deployed? Is that separate process on? Is that just tied into as a user agent or?
Right. So it's actually our health system is an application that's running. And it's tied in. You can tie it in through as a user agent, or you can actually, list your separate JMX values that you want pulled from your application itself, similar to like JConsole, looking at it through there. But the overhead of the health system is 1% to 2%. So it's something that, it's that added visibility and sort of the added confidence that gives people, the pertinent information. I say pertinent, but again, if you guys have used Nagios or something like that, there's tons of other stats out there to look at within the application. But from our standpoint, again, our health monitoring really evolved from a need to support our end users. So we weren't trying to build a system to compete with some of the other monitoring tools out there. We were just trying to build a system that's going to find us the root cause for a lot of solutions, and that's really what you see with the monitoring going on.
So it's definitely kind of localized to that, just monitoring one application server per process.
Exactly.
And someone else asked about communication. There's no communication between the two. I guess that's why you're kind of saying it's not a replacement for Nagios or any one of these. It's very localized to this one application server instance, right?
Yes, however, it's localized to the cluster, so so you can monitor across your cluster from the Resin admin, and your cluster can be deployed. Geographically, we have clusters who one server is sitting in Amazon, one server is sitting on their in-house, and then the other one is, somewhere on the East Coast, right? So yeah.
So you're not having it. Gotcha. Makes sense.
Is there any session persistence if the monitor restarts one of the servers? Will it transfer it over to
Yes, so it's configurable, but if it's turned on, if session storage is on, then yes. What will happen is, the monitoring doesn't really impact it. What happens is, a copy of the session data from the server that went down is available on one of the other servers in the cluster. So server A goes out. While server A is out, you have servers B and C still spinning and answering all the requests out there. So there's no sort of session loss or no impact from the client. So a client may be switched. You saw the AAA. They may start a session out on server AAA, and without any interruption to them, end up on server C. But server C is aware of all that data that was pushed over. So.
Okay, great. Thank you very much.
Great.
Great. So, thank you everybody.